Now let's learn our 3 times table. 0 times 3 is 0. 1 times 3 is 3. 2 times 3 is 6, because if we have 2 groups of 3 counters, we have 6 counters altogether. 3 times 3 is 9, because if we have 3 groups of 3, we have 9 altogether. 4 times 3 is 12. 5 times 3 is 15. 6 times 3 is 18. 7 times 3 is 21. 8 times 3 is 24. 9 times 3 is 27. 10 times 3 is 30. 11 times 3 is 33. And 12 times 3 is 36. Zero times 4 is 0. 1 times 4 is 4. 2 times 4 is 8, because if we have 2 groups of 4 counters, we have 8 counters altogether. 3 times 4 is 12, because if we have 3 groups of 4 counters, that gives us 12 counters. 4 times 4 is 16. 5 times 4 is 20. 6 times 4 is 24. 7 times 4 is 28. 8 times 4 is 32. 9 times 4 is 36. 10 times 4 is 40. 11 times 4 is 44. And 12 times 4 is 48. Now we need to connect the 2 times table and the 4 times table. So every number that's in the 4 times table is also in the 2 times table. Every multiple of 4 is also a multiple of 2. And to see why that is, on this top number line here, we can write out our 2 times table, and then on this bottom number line, we can write our 4 times table. So with our 2 times table, counting in steps of 2, we have 2 and then 4, and the first multiple in our 4 times table is 4. So 2 times 2 is the same as 1 times 4. Now if we keep going with our 2 times table, next we have 6 and then 8. So 4 times 2 is 8, and 2 times 4 is also 8. You can see that in our 2 times table, we now have got an extra 4 counters, and we've got an extra 4 counters in our 4 times table as well. Carrying on, counting in 2s, we have 10 and then 12. So that's given us another 4 counters. If we keep counting in 4s, the next multiple of 4 is 12. So 12 is 6 times 2 and 3 times 4. Counting on in 2s, we have 14 and then 16, and 16 is also the next multiple of 4. So we've got 4 more counters up here, and of course with our 4 times table, we have 4 more counters here as well. And we can keep going, so 18 and then 20, 10 times 2 is 20, and 5 times 4 is also 20. Again, we have another 4 counters in both. Then 22 and 24, so 12 times 2 is 24, and 6 times 4 is also 24. Now if we carry on with our 4 times table, next we have 28. And if we were to continue counting in 2s past 24, we would also get to 28. Next we would have 26, then 28. And if we carry on counting in 4s, we have 32, 36, 40, 44, and 48. And it's important to understand that all of these numbers would also be in our 2 times table if we kept on counting in twos. Notice with the 4 times table, numbers always end in 2, 4, 6, 8 or 0. So numbers in the 4 times table or multiples of 4 are always even numbers, and any even number is always in the 2 times table. Any even number is a multiple of 2. Now we can see here we've got our 2 times table written out and our 4 times table as well. Now notice, if we double what's in the 2 times table, we get what's in the 4 times table. Remember, to double a number, we're adding the number to itself or multiplying it by 2. So 2 times 2 is 4, 4 times 2 is 8, 6 times 2 is 12, and so on. Or looking at it the other way, if we halve what's in the 4 times table, we get what's in the 2 times table. Remember, to halve or to find half of a number, we divide it by 2. And 4 divided by 2 is 2, 8 divided by 2 is 4, 12 divided by 2 is 6, and so on. And that's why 1 times 4 gives us the same answer as 2 times 2. 2 times 4 is the same as 4 times 2. 3 times 4 is the same as 6 times 2. 4 times 4 is the same as 8 times 2. 5 times 4 is the same as 10 times 2. 6 times 4 is the same as 12 times 2. And all of our other multiples of 4 would also appear in the 2 times table if we carried on our 2 times table past 12 times 2. Now, what we can show here on these first 2 number lines is our 2 times table, and then on this bottom number line, our 4 times table. So 1 times 2 is 2, and if we show that twice, we have the same as 1 times 4, because we have 4 counters altogether. 2 times 2 is 4, but if we show that twice, we have 2 times 4. Now, 3 times 2 is 6, and if we show that twice, then we've shown 3 times 4, because 3 times 2 is 6, but if we show 6 counters twice, we've shown 12 counters altogether. Then 4 times 2 is 8, and 4 times 4 is 16. 5 times 2 is 10, and 5 times 4 is 20. 6 times 2 is 12, and 6 times 4 is 24. 7 times 2 is 14, and 7 times 4 is 28. 8 times 2 is 16, and 8 times 4 is 32, because double 16 is 32. 9 times 2 is 18, and 9 times 4 is 36. 10 times 2 is 20, but if we double 20, we get 40, and that's why 10 times 4 is 40. Then 11 times 2 is 22, and 11 times 4 is 44, and 12 times 2 is 24, and if we double 24, we get 48, so that's 12 times 4. So now we have our 4 times table on this top number line, and our 2 times table below. Now if we take half of these counters showing the 4 times table and get rid of half, you can see that what we have is our 2 times table. And that's why if we halve what's in the 4 times table, we get what's in the 2 times table. So half of 4 is 2, half of 8 is 4, half of 12 is 6, and so on. Now we can show our 100 square, and here we have our 2 times table highlighted. Now we can see the 2 times table on 100 square makes a really obvious clear pattern. We have numbers that end in 2, 4, 6, 8 or 0 shaded in. But now let's show numbers in our 4 times table, or multiples of 4 on our 100 square. Again, you can see that we get a pattern, and you can also see that again, just like with the 2 times table, multiples of 4 always end in 2, 4, 6, 8 or 0. So if a number ends in a 1, 3, 5, 7 or 9, so if a number is an odd number, we know that it's not going to be in the 4 times table. Now let's learn our 8 times table. 0 times 8 is 0. 1 times 8 is 8. 2 times 8 is 16, because if we show 2 groups of 8 counters, we get 16 counters altogether. 3 times 8 is 24, because if we show 3 groups of 8, that gives us 24. 4 times 8 is 32. 5 times 8 is 40. 6 times 8 is 48. 7 times 8 is 56. 8 times 8 is 64. 9 times 8 is 72. 10 times 8 is 80. 11 times 8 is 88. And 12 times 8 is 96. Now we need to connect the 4 times table and the 8 times table. Now every number that's in the 8 times table is also in the 4 times table. And to see that and to understand why that is, on this top number line here, we can show our 4 times table, and then on this bottom number line, our 8 times table. So counting in 4s, we have 4 and then 8, and 1 times 8 is 8. So notice 2 times 4 gives us the same answer as 1 times 8. If we continue counting in 4s, we have 12 and then 16. But that's given us another 8 counters altogether. And of course, if we keep on counting in 8s, we get another 8 counters as well. So 4 times 4 is the same as 2 times 8. We can keep going. So next we have 20 and then 24, and 24 is our next multiple of 8 as well, because in both number lines we've now got 8 more counters. Then we have 28 and 32, and 32 is the next multiple of 8. We have 36 and then 40, so 10 times 4 is 40, and 5 times 8 is also 40. So notice every number that's in the 8 times table is in the 4 times table as well. We have 44, and then 12 times 4 is 48. And because 12 times 4 is 48, we know that 6 times 8 must be 48 as well. And we can keep on counting in our 8 times table, and it's important to understand that all of these numbers that are in our 8 times table would also be in our 4 times table if we kept on counting in 4s. Now you can see here we have our 4 times table and our 8 times table written out. And if we double what's in the 4 times table, we get what's in the 8 times table. Remember, to double a number, we add it to itself or multiply it by 2. 4 times 2 is 8. 8 times 2 is 16. 12 times 2 is 24, and so on. And looking at it the other way, If we halve what's in the 8 times table, we get what's in the 4 times table. Remember, to halve or to find half of a number, we divide it by 2. 8 divided by 2 is 4, 16 divided by 2 is 8, 24 divided by 2 is 12, and so on. And you can see every number in the 8 times table, every multiple of 8 is also a multiple of 4. So 1 times 8 is the same as 2 times 4. 2 times 8 is the same as 4 times 4. 3 times 8 is the same as 6 times 4. 4 times 8 is the same as 8 times 4. 5 times 8 is the same as 10 times 4. 6 times 8 is the same as 12 times 4, because notice double 6 is 12 and half of 8 is 4. And all of these other numbers in our 8 times table would be in our 4 times table as well if we kept going past 12 times 4. So we know that if we double the 4 times table, we get the 8 times table. And to show that, on these top 2 number lines, we can show our 4 times table, and then we can write out our 8 times table on this bottom number line. So 1 times 4 is 4, but if we show that twice, we get 1 times 8, because we have 8 counters altogether. 2 times 4 is 8, and if we show that twice, we get 16, which is 2 times 8, because we now have 16 counters altogether. 3 times 4 is 12, but if we show that twice, we have 24 counters altogether, and that's why 3 times 8 is 24. 4 times 4 is 16, and if we double 16, we get 32. 5 times 4 is 20, and double 20 is 40, so that's why 5 times 8 is 40. 6 times 4 is 24, and 6 times 8 is 48. 7 times 4 is 28, and 7 times 8 is 56. So 28 is half of 56, or double 28 is 56. Then we have 32, and if we show that twice, we get 64. Then 36, if we show that twice, we have 72, because 9 times 8 is 72. Then 10 times 4 is 40, which means that 10 times 8 is 80. 11 times 4 is 44, and 11 times 8 is 88. 12 times 4 is 48, and 12 times 8 is 96. So now, on this top number line, we have our 8 times table, and we have the counters shown below. But if we split these counters in 2 and take away half of them, you can see that what we have left gives us our 4 times table. And that's why if we halve what's in the 8 times table, we get what's in the 4 times table. So half of 8 is 4, half of 16 is 8, half of 24 is 12, and so on. So now we can see the 4 times table written out on 100 square. And we know that every number in the 4 times table is an even number, so ends in a 2, 4, 6, 8 or 0. But now, if we show our 8 times table, so our multiples of 8 on 100 square, you can see that again we get a similar pattern. Every multiple of 8 also ends in a 2, 4, 6, 8 or 0. So multiples of 8 are always even numbers as well. And notice all of these numbers that we have highlighted, we also had highlighted when we showed our 4 times table. So every multiple of 8 is also a multiple of 4. Now it's important to understand that we can multiply numbers in any order. So 5 times 2 is the same or equal to 2 times 5. 5 times 2 is 10 and 2 times 5 is 10 as well. And to see that, we can show an array. So looking at it this way, we can have 5 groups of 2 because 2 plus 2 plus 2 plus 2 plus 2 is 10. So 5 lots of 2 makes 10. But if we look at our array the other way, we can also see that we have 2 groups of 5. And 5 plus 5 is 10 as well. Now here, 4 times 3 is 12, and that's the same as 3 times 4. So with our array, we can either look at it this way, so with 4 groups of 3, because 3 plus 3 plus 3 plus 3 is 12. But if we look at it the other way, we can also think of this array as showing 3 groups of 4, and 4 plus 4 plus 4 makes 12 as well. So that's why 4 times 3 gives us the same answer as 3 times 4. We can multiply numbers in any order. Now for these questions, we need to multiply or multiply by a multiple of 10, so a number that ends in a 0. First, we have 3 times 80. Now that's 240, because if we know that 3 times 8 is 24, we know that 3 times 80 is 240, so that's 24 with a 0 on the end. If we have an end 0 in a multiplication question, there will be an end 0 in our answer as well. Now 40 times 8. Well, we know that 4 times 8 is 32, and that means 40 times 8 must be 320. So 32 with a 0 on the end, because we have a 0 in our multiplication question. If we know 4 times 8 is 32, we know 40 times 8 is 320. And finally, we have 9 times 20. If we ignore the 0 for a moment, we know that 9 times 2 is 18. So we can write 18, but then put a 0 on the end, because if we have an end 0 in a multiplication question, there will be an end 0 in our answer as well. Now on a number line, for 3 times 80, we can show 3 jumps of 80. So we have 80, 160, 240. So if we keep on adding 80 each time, we get 80. Then if we add another 80, we get 160. So that's 2 times 80. But then if we add another 80, we get 240. Because 3 times 80 is 240. And you can see that counting in steps of 80 is just like counting in steps of 8, but with a 0 as our ones digit. Then we had 40 times 8. Now we could show 40 jumps of 8 on our number line, but that would take us a very long time. So instead, let's show 8 jumps of 40, because remember, with multiplication, order doesn't matter. So if we count in steps of 40, we get 40, 80, 120, 160, 200, 240, 280, 320. So counting in steps of 40 is just like counting in steps of 4, but with a 0 as our ones digit. Because if we're counting in steps of 40, we're counting in steps of 4 tens. And finally, we had 9 times 20. So if we count in steps of 20, we get 20, 40, 60, 80, 100, 120, 140, 160, 180. So because we've added 20 each time and we've made 9 jumps, we know that 9 times 20 is 180. And again, we can see counting in steps of 20 or counting in steps of 2 tens is just like counting in steps of 2, but then with a 0 on the end. Now, if we look at these questions a bit more closely, first we had 3 times 80. So we can show 3 jumps of 80. We have 80, so instead of 8 ones, because 80 is 8 tens, we can show 8 tens below what we jump each time. Then the next multiple of 80 is 160, but because we wanted 3 times 80, we needed to make a third jump, and that gave us 24 tens altogether. But if we have 24 tens, we have 240, so with a 0 as our ones digit. So remember, counting in steps of 80 is just like counting in steps of 8, but then with a 0 as our ones digit, because with 80, we're adding 8 tens each time. Then we had 40 times 8, which is the same as 8 times 40. So counting in steps of 40, we have 40, so we can show 4 tens below what we count each time. Then if we add another 4 tens, we have 8 tens, so that's 80. Then 120, 160, 200, 240, 280, and then 320. So we made 8 jumps of 40, and that's taken us to 320 because we have 32 tens. And if we have 32 tens, we could regroup those into 300s and 2 tens. So counting in steps of 40 is just like counting in steps of 4. Then for our last question, we had 9 times 20. So we can make 9 jumps of 20. We have 20, 40, 60, 80, 100, 120, 140, 160, and then our 9th jump takes us to 180. So 9 times 20 is 180, because we know that if we had 1s instead of 10s here, 9 times 2 is 18. So if we have an end zero in our multiplication question, we can ignore it, do the multiplication, and then put an end zero on the end of our answer. Now we need to multiply or multiply by a 2-digit number using the grid method. First, we have 4 times 55. So what we can do is first of all partition our 2-digit number into tens and ones. With 55, we have 5 tens, so that's 50, and 5 ones, so that's 5. So to get our answer, we're going to multiply 4 by 50, then multiply 4 by 5, and then add up our answer. So on our grid, we can write our single-digit number on the left, and then our partitioned number, so 50 and 5 on top. Now 4 times 50 is 200. That's because 4 times 5 is 20, but because we're multiplying by a multiple of 10, we need to put a 0 on the end of our answer. Then for this box here, we can work out 4 times 5, so that's 20. And finally, we can add up our answer boxes, and 200 plus 20 is 220, so that's our answer. Now we have 23 times 7. Again, we're going to start by partitioning our two-digit number. 23 is 20 and 3. So we can multiply 7 by 20, then multiply 7 by 3 and add up our answers. So on our grid, again, we can write our single-digit number in the question on the left and our partitioned number, so 20 and 3, on top. Now, 7 times 20 is 140, because 7 times 2 is 14, but because we're multiplying a multiple of 10, we need a 0 on the end. Then, for this box here, we have 7 times 3, so that's 21. So the last thing to do, again, is to add up our answer boxes, and 140 plus 21 is 161, so that's our answer. So now, let's take a closer look at this first question. We had 4 times 55. On our grid, we partitioned 55 into 50 and 5. So for 4 times 50, we can show 50 4 times, and that gives us 20 tens, so 200. Then for this box here, we can show 4 times 5, so we can show 5 4 times, and that gives us 20. So altogether, we get 220. Or, looking at it the other way, we can show 55, so there's 5 tens and 5 ones. Because 4 is the other number in our question, we can show what we have here. We can show 55 4 times. Then you can see we get 200 by multiplying 4 by 50, because 20 tens means that we have 200. And we have 20 here, because 4 times 5 is 20. So it's important to understand that if we know our 50 times table and our 5 times table, we can work out our 55 times table. 50 times plus 5 times will equal 55 times. So because we wanted to work out 4 times 55, we could work out 4 times 50, work out 4 times 5, and then add up our answers, because 200 plus 20 is 220. Then the other question we looked at was 23 times 7. So we wrote 7 on the left of our grid, and then 20 and 3 on top. To show 7 times 20, we can show 20 7 times. That gives us 14 tens, which is the same as 140. Then for this box here, we can show 7 times 3. So we can show 3 7 times, and that gives us 21. And putting what we have together gives us 161. Or we can show 23 as 2 tens and 3 ones, and because we're multiplying by 7, we can show 23, we can show what we have 7 times. Then you can see here we get 140 because we have 14 tens, so we could regroup those into 104 tens. And here we have 21 because 7 times 3 is 21. So it's important to understand that if we know our 20 times table, or can work it out, and we know our 3 times table, then we can work out our 23 times table. If we add our 20 times table and our 3 times table, we get our 23 times table. So because we needed to work out 7 times 23, we could work out 7 times 20, then work out 7 times 3, and then add up our answers. Now we need to multiply a 2-digit number by a single-digit number using expanded column multiplication. So first we have 33 times 2. We can set the question out like this, with our 2-digit number on top and our single-digit number below. Now here we have 2 answer lines. That's because in this first answer line, we're going to multiply our ones digit by 2. Then on our second answer line, we're going to multiply our tens digit by 2. And then we're going to add up our answer lines. So on this first answer line, multiplying the ones digits, we have 3 times 2, so that's 6. Now, onto our second answer line, we can write a 0 in our ones place value column, and that's because we're multiplying by the 3 that's in our tens this time. So 3 times 2 is 6, and then all we need to do is add up our answer lines to get our answer, so that's 66. Notice on this second answer line, we wrote 60 because 3 tens is 30 and 30 times 2 is 60. So that's why we could just write a 0 on the end, and then rather than multiplying 30 by 2, we could just multiply 3 by 2, because that gives us the same answer as multiplying 30 by 2. So now let's try 76 times 5. Again, we can set the question out with our 2-digit number on top, and we'll need 2 answer lines. On our first answer line, remember we're multiplying the ones digit, and 6 times 5 is 30. Then on our second answer line, we can write a 0 on the end, so a 0 in our ones place, and 7 times 5 is 35. So now we just add up our answer lines, and that gives us 380. Finally, we have 85 times 3. 5 times 3 is 15. We write a 0 on the end of our second answer line in our ones place because we're multiplying our 8 tens. 8 times 3 is 24, so then we just add up our answer lines to get 255. Now let's think about why this method works, and let's take a closer look at this first question. We had 33 times 2. Now we can represent 33 with 3 tens and 3 ones, and if we're multiplying by 2, we can show 33 twice. Notice when we do that, we get 6 ones up here, which is why we write 6 in our first answer line, and we get 6 tens, so that's why we write 60 in our second answer line. So altogether we have 66 represented here. Then we had 76 times 5. So we can represent 76 as 7 tens and 6 ones. We're multiplying by 5, so we can show 76 2, 3, 4, 5 times. So now altogether we have 30 ones, which is why we write 30 as our first answer line, and then below we have 35 tens, so that's 350 because we could regroup these tens into 300s and 5 tens. So that means that we have 380 altogether. Then for our last question, we had 85 times 3. 85 means we have 8 tens and 5 ones, and to multiply by 3, we can show what we have 3 times. Then you can see where we get 15 because we have 15 ones altogether here, and then below we have 24 tens, which is the same as 240. So putting all of what we have together gives us our answer 255. Now let's multiply using short multiplication. First we have 16 times 4. So we can set the question out like this, with our 2-digit number on top. But unlike with expanded multiplication, here we only need one answer line. We're going to start by multiplying our ones digit, and 6 times 4 is 24. But because 24 is a 2-digit number, we need to write our first digit above the next place value column along. So 6 times 4 is 24, so we write that 2 4. Now we move on to our next digit, so on to our tens digit. 1 times 4 is 4, but what we need to do now is add the 2 that's on top. So 1 times 4 is 4, plus 2 is 6, so our answer is 64. Now 24 times 3. We set the question out in the same way and again start by multiplying our ones digit. 4 times 3 is 12, but that's a 2-digit number, so we write 12 as 1, 2, again with the first digit above the next place value column along. Now onto our tens. 2 times 3 is 6, plus 1 is 7, so our answer is 72. Finally, we have 2 times 35. Now remember, with multiplication, order doesn't matter, so we set the question out in the same way, with our 2-digit number on top, even though for this question, the 2-digit number is the second number. We start by multiplying our ones digit, and 5 times 2 is 10, so that's 1, 0. Then onto our tens. 3 times 2 is 6, plus the 1 that's on top gives us 7, so our answer is 70. So now let's take a look at why this method works. So why, when we get a 2-digit answer, we write the first digit above the next place value column along. For our first question, we had 16 times 4. Now we can represent 16 with 1 10 and 6 ones, and because we're multiplying by 4, we can show 16 2, 3, 4 times. Now you can see that we have 24 ones on top, but we can regroup those into 2 tens and 4 ones. So that's why we write 4 as the ones digit of our answer, because now that we've regrouped, we have only 4 ones. And we write 2 above the next place value column along, so here above our tens column, because now that we've regrouped, we've made 2 extra tens. Now what we have below these 4 tens here, we got from multiplying 1 10 by 4, but because we've made 2 more tens, that means that we have 6 tens here altogether. So that's why our answer is 64. Then we had 24 times 3. So we can represent 24 with 2 tens and 4 ones. We're multiplying by 3, so we can show 24 3 times. Doing that gives us 12 ones, but if we have 12 ones, we can regroup 10 of those ones to make 1 extra 10. So that's why we write 2 as the ones digit of our answer, because now that we've regrouped, we only have 2 ones. And we write 1 above our tens place value column, because multiplying our ones digit has meant that we can make 1 extra 10. Now the 6 tens that we have below, we got from multiplying 2 tens by 3. But because we've made 1 extra 10, we have 7 tens altogether. So that's why we get 72. Then for our last question, we had 2 times 35. Now we can represent 35 with 3 tens and 5 ones, and because the other number in our multiplication is 2, we can show what we have 2 times. Doing that gives us 10 ones, but if we have 10 ones, we can regroup those into 1 10. So now we don't have any ones, which is why we have a 0 as the ones digit of our answer. Multiplying our ones digit meant that we made 1 extra 10, and we have 6 tens below because 3 tens times 2 is 6, but that means that we have 7 tens now altogether, so that's why our answer is 70. Now we're going to multiply using short multiplication, but this time we're going to get 3-digit answers. So first we have 24 times 6. We can set the question out like this with our 2-digit number on top and because we're using short multiplication, we only need one answer line. Now we start by multiplying our ones digit. 4 times 6 is 24, but we write that as 2, 4. So with our first digit of the number above the next place value column along, so above our tens. Now we can move on to multiplying our tens digit. 2 times 6 is 12, but we need to add the 2 that's on top. So 2 times 6 is 12, plus 2 is 14. Now normally we write the first digit above the next place value column along, but because we don't have any more digits to multiply, we can just write the 14 in our answer line. So that gives us 144. Now let's try 74 times 2. We can set the question out in the same way, and we start by multiplying our ones. 4 times 2 is 8, and that's just a single digit number, so we can write 8 in our answer line, and we don't need to write anything above the next place value column along, because 4 times 2 is 8, and that's only a one digit or single digit number. So we can move straight on to the tens. 7 times 2 is 14. We don't have anything to add, and we don't have any more digits to multiply. So 7 times 2 is 14, and we can just write that in our answer line to give us an answer 148. Finally, we have 3 times 45. So here the single digit number is written first, but that doesn't matter, because with multiplication, order doesn't matter. So we can set the question out in the same way, with our 2-digit number on top. Starting with our ones, 5 times 3 is 15, so that's 15, with the first digit above our tens. And now 4 times 3 is 12, plus 1 is 13. And we can just write 13 in our answer line because we don't have any more digits to multiply. We don't have any other digit or any other place value to write the first digit above. So our answer is 135. Now let's take a closer look at these questions and see why this method works. So why, if we get a 2-digit answer, we write the first digit above the next place value column along, but if we don't have any more digits to multiply and we get a 2-digit answer, we can just write that in our answer line. First, we had 24 times 6. So we can represent 24 with 2 tens and 4 ones. We're multiplying by 6, so we can show the 24 2, 3, 4, 5, 6 times because we're multiplying by 6. Now doing that means that we have 24 ones, but we can regroup. When we have 10 ones, we can regroup those to make one 10, and here we can do that twice. We also know that when we have 10 tens, we can regroup those into 100. So now that we've regrouped, let's look at what we have. We have 100, we have 4 tens, 1, 2, 3, 4, and we have 4 ones. So that's why our answer is 144. Now our next question was 74 times 2. So we can represent 74 with 7 tens and 4 ones, and because we're multiplying by 2, we can show that twice. Now here we only have 8 ones, so we can't regroup those. We can't make an extra 10, which is why we don't have anything written above our tens digit. But we can regroup 10 of our tens to make an extra 100. So that gives us 100, 4 tens, and 8 ones, so 148 as our answer. Then our last question was 3 times 45. So we can represent 45 with 4 tens and 5 ones, and because the other number in our multiplication is 3, we can show what we have 3 times. Now here we have 15 ones, so we can regroup those into 1 10 and 5 ones, which is why we write 1 above our tens column and 5 as the ones digit of our answer. But now we have 13 tens. We can regroup 10 of those tens to make an extra 100, and doing that means that we get 103 tens, so 135 as our answer.